All right, let's just do a real quick recheck of absolute value inequalities. Absolute value inequalities are always a very difficult concept in algebra. They're confusing, but the general thought is, first of all, we attack these less than absolute value inequalities much differently than we do the greater than absolute value inequalities. That is the first real thing to understand about these. If you have a less than absolute value inequality where it's set less than a constant, a positive constant, more on that in a second, we solve this by sandwiching this expression between -6 and +6. So what we're looking for is for this expression -3x plus 8. This is the expression inside the absolute values. We want this expression to be strictly less than 6 and greater than -6. Two important things. First of all, the absolute value doesn't in any way affect the negative here and make it positive. It doesn't happen. What we want is the expression on the inside here to be sandwiched between +6 and -6. If this question, for instance, had an less than or equal to sign here, the only effect is we're going to put little equal signs here, which will slightly affect our final answer. We attack the greater than absolute value inequalities differently than we do the less than. For the less than, we want them sandwiched in between two values. For the greater than absolute values, we're going to get two disjoint sets. We find those sets by taking this expression 4x minus 3, and we want it to be greater than 10. Or we want this expression 4x minus 3 to be less than -10. Again, the biggest difference between these two types of absolute value inequalities are the solutions we get. When we have a less than absolute value inequality, we get this nice interval. When we solve a greater than absolute value inequality, we always get these two disjoint intervals. Let's now talk about two unique situations that finish the conversation of absolute value inequalities. The important thing here is the two methods I just described for absolute value inequalities are all based on the fact that you have a positive value here on the other side of the absolute value. In this case, we have the absolute value of this expression has to give us something less than -7. The key here is an absolute value expression can never be less than a negative number. It always will produce 0 or positive. The absolute value then can never be less than a negative. Again, the negative here matters, the negative in here does not matter. So in this case, we have no solution to this absolute value inequality. The absolute value cannot be less than a negative. We would say it's the empty set, or we could write DNE for a solution does not exist to this inequality. The solution for the greater than absolute value inequality is actually completely different. In this case, the absolute value will always be greater than a negative value because it produces 0 or positive values. So in this case, we have all real numbers. And in interval notation, we would simply write -∞ to infinity. It's the unbounded set of all real numbers.